but you should be feeling pretty good. We did that one. So let's look at this. On this guy, it says, suppose you wanted to use the limit comparison test. And it looks really weird, right? That one looks tough. But when I use the limit comparison test, I say, okay. I go and I look, and I ignore all but the biggest and the biggest. Agreed? So let's see what I'm going to compare it with. What's the biggest on the top, ignoring coefficients, is just 1. And what's the biggest on the bottom?
E to the n.
E to the n. So I just kind of ignore all but the biggest as I'm looking at this limit comparison test. And before we jump and say, yeah, I think it's A, let's just make sure it all works out. Okay? Just for a review as well, especially since notes didn't go pretty well. Okay, so here, this guy's the same as, how can I rewrite that?
E to the negative n.
Well, 1 over E, because 1 to the n is just 1. And why would I write it like that? Geometric. So what does this guy do? It's like 1 over, E is what, 2.7-ish? So even just think 1 over 2 or 1 over 3. Both of those, geometric, the absolute value of r is less than 1, greater than 0. Is that true for that? Well, it's in between 1 over 2 and 1 over 3, right? The 1.27. Okay, so it is. Okay, so what does this guy do? It converges by geometric. Okay, so that's the first one that I think I want to compare it with. So let's go ahead and do the limit. And what's the notation? The limit as what? N goes to infinity. That's going to be the case every time we take a limit for series, okay? We're always looking at the limit as n goes to infinity when we're taking those limits. And I start with the original divided by the new, which is the same as multiplying by the reciprocal. And what do I get out? 1. Did the test fail? Did the test work? The test worked because 1 is both what? Finite and positive. The test would have failed and we would know nothing if I got 0, a negative, infinity, or negative infinity. Agreed? Then the test would just fail and we have to try something else. So therefore, since this guy converged, what do I know this one's going to do?
Converge.
Converge by the limit comparison test. Can I put LCT on my test or on my quiz?
Nope.
No. Only these things. Okay. So was A good? Yes. Questions on that? Okay, so let's do one more. Or actually 2 more, sorry, and then we'll go on to today's notes. 10 should take you 10 seconds. Okay, so what's the biggest on the top?
N squared.
What's the biggest on the bottom? Which reduces to just 1 over n, which is good. Okay, one more that we're going to do. Now, a lot of times we do a substitution when we have the sines and cosines. But in this case, we're not going to do a substitution because it's not a fraction. It's just the n to begin with. And in fact, if I look at this, what's the biggest on the top? N. What's the biggest on the bottom? Is it going to be a sine squared n or an n squared? An n squared. That sine squared n in this particular case is just inconsequential, okay? Because it's not the biggest. So in all actuality, which one am I going to compare it with? 1 over n again. You see that difference? Now go back to your essential questions. And look at the difference in the b. I think you do a here in a little bit on your own. Okay, but look at b. You see how the sign has a fraction within it and there's nothing else going on? That's when we actually look at the inside of the sign for our new limit, and for our new series that we're going to compare it with. You see that difference? Okay, so what are we going to compare b with? It's the inside, which is 1 over n. Let's do this limit again together. That becomes the limit as n goes to infinity of the original divided by the new. And this is when I need to do a substitution now. What am I going to let 1 over n equal? Easy variable. I'm going to pick x. See if you can finish this down. We've been doing this since chapter 1. Yeah, we haven't went to the point yet. We're just finishing up the point. I just wanted to do this one more time together. Okay, so did you get the limit as x goes to 0 of 3 sine x over x now? Which would be 3 times 1, which is 3. That's our special limit, right? Sine x over x as x goes to 0. Or you could have done L'Hopital's. So 3 is both finite and positive. So this guy is going to do the same as this guy. And this guy did what? Diverged by the p series. This is what series? Harmonic, which means this guy also diverges. They just have to do the same. Okay, by the limit comparison test. All right. Okay, so now let's go ahead and start 8.5. We'll fill in our flippies for everything at the end, okay? Okay. Okay. I believe you. Something like this. Everybody. Okay. It's a song, but it's from Beetlejuice.
I'm just repeating what it was. That's what Water said.
The meanies.
Water said 80s.
Okay. So today we're going to be dealing with the alternating series test. And you're going to like this. It's a lot easier than thinking through like the limit and the directs. Okay? The directs and the limits take the most thought. Okay. Alright. So alternating series. So the alternating series is basically when I see this guy going on right here, or I could have that. What happens is I plug in 1, 2, 3, 4. What does that do? It makes it go positive, negative, right? right? Or negative, positive, or positive, negative, positive. So it's making the signs alternate. Well, yes, but since we're doing, okay. Okay, so it's making the signs alternate. Just like this part right here, do you agree I could have reduced negative 1 to the n, negative 1 to the first, and said that's negative, negative 1 to the n? Is that okay? Okay, so that part that I circled in green, that is the alternating part. Okay? That tells me, hey, we got an alternating series going on. We're going to do the alternating series test. Okay. Two things you have to show for the alternating series test. First, you have to show that the limit is 0 of just the a sub n. You're doing the limit without the alternating series part. Do you see that? So you're only taking the limit, you ignore that negative 1 to the n part. Okay. First you go and you show the limit is 0. Showing the limit of 0 tells us what so far? Tells us nothing. Okay? It's just one, it tells us, hey, this could converge, but we don't know yet. Okay? It's saying, I have an inkling that I think it's going to converge, but okay, let's just really quick do this one. What's the limit? Just really, little side note here, Bar. What's the limit here? Bar, little side note, what's this limit? 0. But what do I know that does? Okay, so does the limit equaling 0 mean it converges? No. The limit equaling 0 tells us nothing so far, basically, okay? However, this is a big but.
Anybody make a joke about it, you're getting in a neck.
If the limit goes of a sub n does not equal 0, what can I say?
Diverges.
It diverges by the term test. Okay. Okay. So if the limit equals 0, we know nothing yet. But hey, if I went and took that limit and it wasn't 0, then I know it's divergent. That's kind of nice. But if the limit equals 0, then now I have to go show one more thing. I have to show that the terms are doing what?
Decreasing.
Decreasing. Okay, so this means that we are decreasing. If I show 1 and 2, then now what can I say?
Converges by alt series test.
Converges by the alternating series test. So this test is not bad. I love this test. Okay.
And it gives you 2 ways of checking.
Okay. Yeah. Anybody one more time? Okay. Jackson. Number 1, how do I know it's an alternating series? So I have that negative 1 to the n. This tells me that I'm going to check for the alternating series. Agreed? Okay. Step 1 in the alternating series test is to take the limit first. Okay, thank you. And then what's the a sub n part? Yeah. So again, we ignore the alternating part and we take that limit. Yes? Okay, and what do I get out? 0, which tells me nothing. Okay, tells me nothing so far. Yes. So now I'm on step 2. Now I have to show that decreasing. Okay, so We're good at this by now, right? I want to show that the next term, that a sub n plus 1, is smaller than the previous term. Can you finish that? I hope so. Actually done this specific one a few times. How fast at it now. Okay, so I have shown it's decreasing for n greater than or equal to 1. Yes? So since I have those two things, hey, I can say that that original guy does what? What does the original guy do? Converges by alternating series test. Good? You think it's going to be fairly straightforward when you use this test?
Yes.
When you see the alternating part, right? Okay. So what happens if I get the limit to 0, but it's increasing?
Diverges.
You use a different test. This test fails. Okay? We know nothing. Okay. Try this one with your buddies. Go.
Isn't this supposed to equal 0? And a equals 1/2, so it doesn't work.
Just by internet.
Each do it.
Thank you. Did I do everything correctly?
Yes. As far as I know.
Hopefully. Okay, questions on that? Everybody good? Cameron? Cameron? Alright, so that's alternating series test. So now here's a cool thing we get to do. Okay?
Oh boy.
I know. Get pumped for this. You getting pumped?
No.
Okay, get pumped. Kayla's pumped, right? Okay. So how many tests do we have?
10.
I didn't call it for a while, but I went to bed.
Okay, we have 10 different series tests. Okay. Of the 10 series tests, which ones can I find the sum? The actual sum? Geometric. I could do like the partial fractions and all that, but like the nth partial sum can help me, right? With all the telescoping and the limit to infinity part. Any more that we've learned so far? No. And in all actuality, out of all 10 of those tests, these are the only 2 that you can find the exact sum. However, we can get really close to it for other guys. And I don't know if you remember in that whole integral thing, and I can go back really fast. I gave you that, and I said, hey, if you want to look over it, great. Do you remember that a little bit? Okay, so you didn't have to, but we could have approximated it. This, we're actually going to learn. This is going to give us an approximation for the sum of an alternating series. Sorry, of a convergent alternating series. We can't find the sum if it's not convergent, right? Okay. And that's what this is going to do. So let's see what this says. It's not that, okay? It says the actual sum, that's the S. And a lot of times we say S sub infinity. So if we went out an infinite amount. So when you just see the S, that means S sub infinity. Okay. So the actual sum. If I went out infinite amount of terms. Minus the sum of just going out in terms. So this is just the sum of n terms. If I took the actual sum and subtracted the sum of n terms, then I have this difference. This difference is the error. Do you agree with that? How close we were. Could I flip-flop it since I'm taking the absolute value? Okay, so this is the error. How close we were off. The error could also be the remainder of the n terms, what I have left to add on. And this is the really cool part. The error is going to be less than or equal to the first omitted term. Okay, so what does that mean in like layman terms? Let's say that I wanted to see the actual sum of something, and I went and I found the sum of the first 4 terms. That's all. So that's like adding a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, right? We added those 4 terms. The error is less than or equal to the next omitted term, which is the 5th term. That's pretty dang cool. Yeah. Okay. So how do you think we could get a better and a better approximation? Because all these terms have to be decreasing in value, right? So if I went out to the 10th versus the 100th, what's the 11th versus the 101st term? Is that going to be a difference if I'm decreasing in value? Yeah, the 101st term is going to be smaller than the 11th term, right? So the more I add up, the smaller my error. Agreed? Okay. Questions on this? So let's go put it in an application. Okay. If possible, use the alternating series remainder theorem to approximate this using the first 6 terms. Why do I say if possible? what do I first have to show? It's convergent, okay? So if possible means I first have to show that it converges. I'll put convergent alternating series. Well, is it alternating?
Yes.
Yeah, there's my alternating part, right? And you go take the first step. And what do we get out? 0, which so far tells me nothing. But it tells me I get to move on to step 2, I guess. And step 2 tells me that I need to make the next term. I want to know, is it smaller than the previous term? Cross multiply. And how do you think I want to rewrite that n plus 1 factorial? Just a guess of what we've been practicing.
N plus 1 times n factorial.
Yeah, because now what do the n factorials do?
Cancel.
They cancel. So I can divide through, right? Divide by basically that n factorial, and I get this. Agreed?
Where did it come from?
N plus 1 factorial is equal to n plus 1 times n factorial. That's what we were practicing in our pre-series. Is that okay?
Yeah.
Okay. And so this is true for n greater than 0. So I can say a sub n plus 1 is less than a sub n for n greater than or equal to 1 is a true statement. And we could have said n greater than 0, but I like using the same number if possible from where it started. Okay, so what do I know? That this guy does what? Converges by the So the impossible is out. It is possible now. So let's go do it. It said using the first 6 terms. So I want to find S what?
6.
Okay, so let's go find S sub 6. So we're going to plug. We're going to use this guy to help us, right? The whole thing. Plug 1 in. What's a sub 1?
1.
Negative 1 to the squared times 1 over 1 factorial, which actually is 1. Plus, or I guess I could say,
Minus 1 half.
minus 1 over 2 factorial, which is the same as minus 1 half. Keep writing out the next few terms on your own. Now walk around if you need help. You guys are going to start getting these factorials down. Just think, 3 factorial is the same as 2 factorial times 3. 4 factorial is the same as 3 factorial times 4. 5 factorial is the same as 4 factorial times 5. Use that to help as you go through. And we see that pattern, yes? Okay, so then this would be 2 times 3, which is 1, 6. This would be 6 times 4, which is 124. That would be 24 times 5, which is 120. And 120 times 6 is 720. Now, I don't expect you to do all this out right now, but it is, I think, 91 over 144. Yeah, 91 over 144. Okay? So let's set up our alternating series remainder theorem, this error bound, basically. We know that the actual sum minus now the
91 over 144.
yeah, the S of 6, which is 91 over 144, is less than or equal to the next omitted term, which would have been, what's the next term? Yeah, 1 over 7 factorial. And if that was a negative, we're taking the absolute value, you guys, okay?
Less than 1 over 540.
Okay, so I know that S minus 91 over 144 is less than or equal to 1 over 540. Did we come pretty close just by doing the first 6 terms?
Yeah.
The actual sum would be? Yeah, that's a pretty good approximation. So the actual sum is within, from this 91 over 144, I could add on 50 over 40, right? And I could subtract off 50 over 40, and that's what my actual sum would be between. Agreed? We could do that with our algebra, dropping the absolute value bars, doing a positive, negative. So our actual sum is somewhere in between those two values. What do you think? You guys aren't so impressed here. This is so awesome. Well, let's see. If I put this, okay, so let's just look at the decimal so you can actually see how close we are. Get out your calculators, which is all put it in. We all have calculators. Point 6, 3,
1746.
1746 and point 6, 3,
2143.
2143. Alright, well we were 2 decimal accuracy with just 2 terms, or with just 6 terms. So I can at least say that it's approximately 0.63. That's really cool. Gosh. What does it take to entertain you? If this doesn't do it, I don't know what will. So the point is that you're adding and adding and adding and adding and adding forever. And you're able to approximate what it's going to be. You want a real life application. Okay, we'll have to work on that. Great. This is right now just the conceptual part of it. The application part is another. And we don't do a ton of the application of the series here, okay? Okay. Now, let's look at this. This is kind of looking ahead, what we're going to be doing in the second part, just so you kind of see. You're going to get X's and N's. It's going to be really, really important that you know what's going on. So I just want us, before we even start reading the problem, I want us to take this guy over. And do you see that it's an alternating series first off?
Yep.
Okay, what tells me alternating series? Okay, so right here I can see that I have an alternating series. When I have x's in it, it's actually going to be a Noah series. Okay. Alright, anyway, I know. Let's write out, for me, try to just write out the first few terms. Let's go to the first, let's just do 4. Okay? So plug in the 1. That's going to be 1 over what factorial? 3 factorial times x to the second. Okay, to the next one. We're only plugging it in for the n, not the x. Does everybody have that so far? Is that okay that you can see how to just plug in the 1, 2, 3? Okay. So basically, now let's read this. They're saying that this guy converges, okay? If the 4th degree Taylor polynomial, and you don't know this yet, but this 4th degree Taylor polynomial means I'm going to come and I'm going to look for the 4th degree down. So the 4th degree down is right here. We're going to learn more about that, but is this okay? Okay. They are saying that it's about 0 and that's where it's centered. We'll talk more about that too. But they're saying that this 4th degree Taylor polynomial is used to approximate f of 1/2. So they are saying that if I plug in f of 1/2, it's approximately 1 over 3 factorial times 1/2 squared minus 1 over 5 factorial times 1/2 to the 4th. That's what they're saying. What is the alternating series error bound? Well, I know that the actual guy minus this approximation absolute value has to be less than or equal to what? From what we just learned. The next term. Here's my next term. But we're actually plugging in what for x? 1/2. So this is saying my s to the infinity, okay, minus my 4th degree Taylor polynomial here, okay, the s of the first 2 terms, it's less than the next term. Simplifying this, well, actually you don't even have to. They have